There are some really exciting updates on Muon colliders. The physicists at the Japan Proton Accelerator Research Complex, J-PARC, have successfully created highly controlled and focused muon beams for the very first time. I have previously discussed why developing a muon collider is essential and the challenges we face. So this breakthrough is particularly significant. The difficulty in having a focused muon beams starts from the production of muons itself. As I have mentioned in the previous video, muons last only for about 2 microseconds. So muons cannot be collected like the protons or electrons. They must be produced on site. The common way in which muons are produced is from the decay of pions, which in itself is produced by colliding proton beams at a target. We can use these pions to produce muons because the pions decay almost instantly and we can collect those muons. And which also means that we don't have pions, and the only way of having them is also by producing them on site with proton beams like this. So that means that the muon beams we need and what we get in the end is a tertiary beam, which is a beam produced by the primary proton beams interacting, producing a secondary pion beam, and from the decay of these pions we get the muons. Such a tertiary beam is in general quite difficult to control. Irrespective of how good the initial proton beam is, the muons so produced will have a large phase space volume, or in other words, it will have a large spread both in terms of position and momentum. To make this beam useful for scientific study, its phase space density needs to be increased. Such a process is generally called cooling, as it reduces the randomness or the chaos of the system, in a way similar to how cooling reduces the vibrations in a microscopic system. So this is where the next difficulty arises. Traditional cooling techniques such as synchrotron radiation cooling or laser cooling or stochastic cooling or electron cooling are not feasible for muons because of their very short lifetime. So there have to be new cooling techniques developed just for muons. One such technique is developed here, which involves the formation of muonium atoms. Here, a beam of anti-muons is made to strike a target, in this case a silica aerogel, and the muon beams can ionize and capture electrons from the silica, forming something equivalent to a hydrogen atom, but instead of having a proton in the middle, we have a positively charged muon. These muonium atoms will have low kinetic energy, as a lot of the momentum it originally had get transferred to the silica molecules during this interaction. So an ionization of these muonium atoms with lasers can be used to produce ultra-slow muons. These muons can then be accelerated into focused electromagnetic fields, and currently they have managed to attain 4% of the speed of light by this technique, and they aim to reach 94% of the speed of light by 2028. But if we need to use muon colliders to probe new physics from what we have done so far, we might need to accelerate muons to at least 99.9999% of the speed of light. So there is still a long way to go, but it is a great feat in the right direction of making smaller and cheaper colliders. Hope you enjoyed the video. If you liked it, please like and subscribe. See you next time with more physics content.